Okay, so this is a group of physics teachers from Deakin, Melbourne, Monash, and now Massey University. And what we're trying to do is to look at the kind of physics teaching that's going on in the junior years of high school, years 7 to 10, with a view to actually trying to think about retention of physics teachers and physics students, and therefore physics teachers and so on. So it's quite an interesting study that's just in its early phases. We've been worried about physics in and declining physics within Victoria and New Zealand, as it turns out, for some time. And one of the factors that has been suggested has been the quality of teaching physics in the junior years. And although most of the teachers of junior science aren't out of field, we do know that there is quite a lot of hesitancy by biology teachers, chemistry teachers, about teaching physics. So it was worth, we thought, investigating. We've as I say, in the middle of collecting data, and we've done a survey of teachers in Victoria, and we've started on doing detailed interviews with teachers in Victoria, and you'll sort of see some of the results in a moment. We want to first off understand what's being done within years 7 to 10 as far as physics teaching goes, but also how both the in-field and the out-of-field teachers feel about that, and then their kind of experiences. And that's been quite interesting to start to think and look at that. So we've done the survey of teachers in Victoria. We're about to do a survey of teachers in New Zealand, and we'll follow that up by looking in detail at some interviews that semi-structured interviews we'll be doing. So here's the teachers we've looked at already. And because of the particular way that we collected data, there are a lot more physics teachers who teach senior physics in our survey data than it went out through the Physics Teachers Association. And so we've only got smaller numbers of teachers who are specialising who teach physics at 7 to 10 rather than teaching it at years 11 and 12 for VCE. But you can sort of see once we start to pull that apart that physics have a definite tendency towards having maths as a second method. Certainly the case with all of my students. There's a second method, maths. Whereas the teachers who are teaching in red, teaching junior science, tend to be more science, junior science specialists and with other disciplines. And when you sort of look at whether they look forward to teaching physics in the junior years compared with how confident they are to teach, you'll notice quite a significant difference there. So there we see that there is significantly lower degrees of confidence. And although senior physics teachers sometimes don't look forward to it, teaching the juniors, they're always very confident. But still there are a significant number of junior science teachers who are confident. So there's kind of quite a lot of spread there in what's being done. I might hand over to Jared for the next slide. Do you want to take over?
Yeah, sure. Thanks, John. I'll pass back to you later. So, and thanks for joining with us, everyone. So going on from that question there about asking people to, talk about their confidence and looking forward to it and sort of seeing those patterns. And I think that limitation John pointed out earlier about the participant numbers is quite important to sort of keep in the back of your mind. If this following question here, which was asking, what support would you find useful to our junior physics teachers? So what would you find useful in terms of the support? What do you need? What would help you for teaching in these year levels, particularly those that were outside of that physics specialisation? And I know Saeed is here, so if you have questions about the particular statistical analysis that he's done, please direct them to him afterwards. But he's developed these concept maps based on the Bayesian statistics to show how different phrases and words are linked together by our participants. And this one here on this page at the moment shows that link between the physics and the teaching. It has that closest sort of distance over to the school at the other side there. So what we saw in the data in terms of what support was useful, you can see down the bottom there some of these quotes, these italicized ones are just direct quotes, looking for examples about how to take some of this content and make it so it's more relevant to the students. So going beyond some just classical representations that might be used to making it more relevant to the students within the school. Moreover, though, we have that closer link between the physics ideas, the physics concepts, and the teaching of it. So thinking about sort of that content knowledge, some curriculum knowledge in there as well, and that pedagogical content knowledge. So how you can break content down, how you can able to manage it in a way to teach it to students, and then pitching it appropriately for different year levels. So it's that real link between the physics and the teaching, so the content and the teaching capabilities, that our junior teachers were interested in terms of support. And if we look at how the physics teachers then saw their perceived role, thanks, John. So a similar sort of question, but just flipped around to focus on our physics teachers, is what do you see as your role? I mean, this is the real key thing that we're interested in, is what is the role that these physics teachers see themselves in supporting these teachers. And you can see from this this concept map that's developed here, those bigger circles sort of that are all clustered together are really around that sort of broader way of thinking about PCK almost, in terms of that engagement, that how to structure content as opposed to just content knowledge, which is out the side there. So it was more around those teaching capabilities. So with our perceived support there, making content more accessible, making it engaging, supporting the non-physics teachers in background, the non-physics teachers without the physics background, and supporting them in terms of aligning things with the curriculum and what concepts are going to be important in terms of that vertical progression. So to support students as they go into, post-compulsory physics, what ideas should they be focusing on, and making sure that they're accurate. There was a lot of information that came through the data, particularly from the physics teachers, about trying to ensure misconceptions are not being taught, and how they'd seen, these sort of classical misconceptions that have been in literature since the 80s coming through in science classes, and how they're trying to support teachers away from those. Similarly, we asked another question around the factors that prevent or support students taking post-compulsory physics. And that was a question that was clustered together as part of the survey. And so teachers interpreted that question in different ways. And so you can see there on this bar graph, most people focused on the prevents side of things. So what was preventing students doing senior physics seemed to be where people focused on, our participants focused on, and some split it into two and offered us supports to think about it and offered us preventions. So for this part of the presentation, we're just going to focus on that right-hand side about what people saw as preventing students from going on into more physics from the physics teacher point of view and the junior science point of view. However, this slide here just shows a cluster of everything. It's sort of quite messy in terms of all these different things that were pulled out under the heading of this question. What prevents students from doing senior physics? So you can see, maths, how it's taught, it's perceived as difficult, confidence in teachers, confidence in students, the reputation of physics. Some people saw physics as being quite boring. So there's a lot of sort of similar things here. But what's more interesting is when we split the data and look at what are the physics teachers saying and what are the years 7 to 10 teachers saying. So in this slide, you've got these, the junior physics teachers focusing, okay, there's not enough physics down in the junior levels. It's very much bio-focused or it's chemistry-focused. There's not much content. That second quote there, the belief that physics is hard, I mean, we could have taken that excerpt from any of the participants from this group, because they all pretty much said something along those lines. It's hard, it's got this reputation for being hard. And then into that, you know, it's poorly taught because the curriculum documents, what they place emphasis on, but also that school context and how the school is focusing on different things. So that graphic there showing, you know, the relationship between these different factors and how physics is being perceived by these teachers and what's preventing them, I think becomes important. And on this next slide is the same sort of question, but from our physics teachers. Now, again, you know, there's a complex concept map here showing all these different things, but that idea of confidence becomes quite a large point. So confidence, and then linking between the physics teaching as well as the role of math. And I can talk about that later in terms of the New Zealand context, but maths comes out a lot stronger there. And that perceived sort of what physics looks like. And again, some of these excerpts here from our teachers talking about what they see as these, you know, things that are preventing these factors. So teachers lacking confidence, teachers not having enthusiasm for it. I mean, if it's outside of their expertise, and then worried about getting, particularly students getting lower scores for university. In one of the interviews that we've done, and not so much presenting that data here, but students worried about how that will affect their ATAR to go into university, and how they've been told by career guidance people, no, even if you want to do engineering, don't worry about physics, focus somewhere else where you can improve your test scores. And our favourite collective excerpt is that bottom one there, around, you know, asking what's going on. It's simple, which is great. You know, we always like to hear things that are simple. If teachers are struggling to have no idea, they're just going to do, they're doing things that they couldn't pass. They're just going to rely on these sort of boring things and making it less engaging, less accessible to students. So those sorts of excerpts, I think, are quite powerful for us. And John, I'll hand over to you to finish off.
Okay, so there's been some really interesting things that have come out from this. And sort of fundamentally, when we look back at that very simple graph that showed in red and blue the negative factors and the positive, you know, those that support, those that inhibit the teaching of physics, you saw that there was actually a commonality, even though that we had more responses from physics, senior physics teachers than teachers of junior science. They both were concentrating on the negatives. And when we started to look at those and start to pull that apart, you saw there was quite a lot of degree of agreement. That, you know, although the confidence varied widely, they all saw that it was the kind of support that they needed to develop, to manage and teach content that was really quite important. And that physics teachers actually saw their role as part of that, as helping support and helping intervene in that area. What they didn't seem to have is the appropriate structures to be able to do that. So how are they going to be able to do that? Where's the time, the space to do that? So that's going to be what we're really going to concentrate as we develop these ideas further, to really start to think about what are the kind of interventions, and to start to look at where we have successfully to start to increase that confidence, decrease the fear of the maths, decrease, you know, improve the quality of experiments that's done and the quality of teaching, move away from PowerPoints, as one of our respondents said. And there's our references, and